everyone. So today we are just working on quadratic functions and equations. That's our new unit. That's chapter 3 and 4 in the textbook. And we will learn about factorizing, sketching quadratic functions, analyzing these functions, describing the transformations that are going on, so reflection, stretches in translations. We'll write an equation in the vertex form. So this is what vertex form is. We'll change the quadratic equation to the vertex form and the standard form. So on something we'll learn, analyzing the equation in standard form, changing quadratic function into standard form using completing the square, analyzing the graph without using a graphing calculator and with using a graphing calculator, explain the relationship between roots, 0, x-intercepts of a quadratic function. We'll solve the quadratic equation in 4 different ways using graph, factorization, completing the square, and applying the quadratic formula. You will select and explain strategies to solve quadratic equation, determine the nature of the root, figure out the discriminant, solve problems that involve quadratic equations, real life problems, and analyzing the quadratic equation. So this is something that if there are a few words you're like, what are you talking about? We'll go over them together as well in the upcoming lessons. But this is kind of like a trailer of what's coming in this lesson. So let's review the methods of multiplying and factoring first. So this is grade 10 stuff. We just need this to is this, you just distribute by multiplying. Okay, if there are two binomials given to you, you use the FOIL method. So first multiply the term that is outside with each of the binomial. So first, then outside, so from x to 6, and then inside, which is 3 times x, and then 3 times 6, which is 18. Okay, so that's your FOIL method. First, outside, inside, and last. Okay, so let's do a few questions together. Now this one is going to be just basic distribution. So 3x squared times 4x, 3 times 4 is 12, x squared times x is x to the power of 3 plus, now we're doing this, right? So it's basically this function. I've drawn the arrow soon. 7 times 3 is 21. X squared stays the same. Now the reason why it became x cubed is because we had x squared times x. Bases are same, powers get added, and you get x cubed. Now we're going to use our FOIL method. 2x times x is 2x squared. Then we'll use outside, so 2x plus 4 is 8x. Then we will do -1 times x, which is negative x, which is inside, right? And then lastly we have -1 times 4, which is -4. And now we will look at our like terms. Here you can clearly see these are my like terms. So my answer would be 2x squared plus 7x minus 4. Okay. Now we have this equation and we need to solve it. So it'll be x minus 5 times x minus 5. So we distribute this, we get x squared, -5x. So we're doing the outside, inside negative 5x again, negative 5 times x is negative 5, and then multiply it by negative 5 times negative 5, which is just positive 25. So your answer will be x squared minus 10x, because minus 5x is minus 10x plus 25. There you go. Okay, so you're just multiplying and simplifying. Now we'll look at factorizing and factoring, and that's opposite of multiplying. So we're looking at finding a common term and basically dividing it to factor out and leave what's left. So tips for factorizing: make sure you look for the greatest common factor. Always remember the greatest common factor is of all your coefficient and the lowest power of your variable factor as well. Don't forget about your variable. And always examine your answer at the end to see if it can be factorized further. Always check for that. Okay, so let's do the first question here. The greatest common factor of 3 and 9. I know 3 can be 3 times 1, 9 can be 3 times 3. So the greatest common factor is 3, right? So that means I'll factor out the 3, but that's just for the coefficient. I need to also look at the variable. So x cubed and x. It can factor the lowest variable, which is x to the power of 1. And we're left with x squared plus 3. So if you're not sure where this came from, it's basically 3x cubed divided by 3x, because we're factoring is opposite of multiplying. We're dividing, so we're just left with x squared. Okay, and that's it. I cannot factor any further, and this is my answer. Okay. Now there are a few questions. Pause the video, try these questions on your own. Okay. Now we're going to look at factoring trinomials. So when the leading coefficient is 1, there are two cases when it comes to factorizing trinomials. And the first one is when the leading coefficient is 1, and the second one is when the leading coefficient is not 1. So the trick with this is you need to factor by inspection. So you look at, this is what your formatting would be when it comes to quadratic equation, because you are missing, your a is basically 1, because when you look at a trinomial, your equation is usually this, right? In this case, a is equal to 1. Okay, so what you do is you set up two brackets for two different binomials, and then the variable of the trinomial goes in the first spot. You determine the two numbers whose sum is b and product is c. Then you use the trick to add to the middle and multiply to the last. Okay, so if you remember product sum factor, that's what they're talking about. So your product would be 1 times c, which is just c. Your sum would be b, and you need to figure out a factor that multiplies and you get c, and when you add it you get b. Okay, so let's do this, and you can check your work by multiplying your binomials at the end to see if you actually factored it properly or not. Okay, let's try the first question here. Your product is 10 and your sum is 7. What are the two numbers that multiply and give me 10 and that add and give me 7? 5 and 2, right? So it'll just be x plus 5 and x plus 2. If we want to check this, we do x times x, which is x squared, plus 2x plus 5x plus 10. And then these are my like terms, so x squared plus 7x plus 10. And that is what this was. So I did factor it properly, and that's my answer. Okay, let's do the next question. X squared minus 6x plus 9. So my product is 9. My sum is negative 6. My factors can be -3 and -3, because -3 times -3 is 9, and -3 plus -3 is -6. So my answer would be this, which is basically x plus 3 whole squared. Okay. The next one. Now in this case, my leading coefficient isn't 1, right? Can I change it to 1? Can I factorize it to have the leading coefficient as 1? Well, yes, I can, because I see that the greatest common factor of 3, 3, and 6 is 3. So you factor out 3, you get x squared minus x minus 2, right? And then now your leading coefficient is 1. So your product is -2. Your sum is -1. Your factors can be -2 and 1. Okay, so you'll be left with 3 times x minus 2 times x minus 1. And again, you can distribute it to figure out your final answer, if this answer is correct or not. Okay. Now the next one, part D, looks a little bit complicated, but we can say that x plus 2 is a. Any variable, you can take it p, you can take it d, you can take whatever you want. Okay. Not x though, because x is already here, so it can get confusing. So let's substitute that. A squared plus 7a plus 12. Okay, my product is 12, my sum is 7. My factors can be 4 and 3. So it'll just be a plus 4 times a plus 3. We'll substitute x plus 2 back in the equation. X plus 2 plus 4 and x plus 2 plus 3. Now, my like terms, 2 plus 4 is 6, x plus 6. And then 2 plus 3 is 5, so x plus 5. And that's my answer. Okay. Make sure when you do assume that x plus 2 is a variable, you substitute it back in. Okay. Okay. So there are a few questions that you're supposed to work on. I know there isn't an answer key, but you can check your work by multiplying out your factors and seeing if it's equal to your original expression or not. Okay, so let's look at this. Now our next case is factoring trinomials when the leading coefficient is not 1, anything but 1. So you look at your common factors first, just like how we did over here. I looked at my common factors. Can I make the leading coefficient 1? If you can do that, amazing. If you cannot, and you still left with the leading coefficient that's not 1, you need to multiply your two numbers. So if you remember, we have ax squared plus bx plus c as a trinomial, right? So we'll have to multiply a and c. And then you add b. So you're trying to find factors that are equal to a times c, and when you add them, you get equal to b. Then you're going to split your x terms into two numbers, and you're going to figure out what's the common factor between the first two terms and the second two terms. Once you get that, each product should have the same binomial factors. Okay, you factor out the common binomial and you expand and simplify to check your work. Okay, so let's do this. So many words, right? Okay, so let's factor this. Well, I can see that there is no common factor of 2, 7, and 3. Right? It's only 1, won't really be helpful. So what I'm going to do is my product is going to be 2 times 3, which is 6. My sum is going to be -7. Now I need to think of two numbers that multiply and give me 6, and add to give me -7. Well, that would be -1 and -6. Okay, so now I'm going to split my terms, my second term, into -6 and -1. Okay, we're gonna split this up. It'll be -6m minus 1m. Doesn't really matter if you put the -1 first or -6 first. Now I'm going to split this up, see what I can get in common. So the first term, I can factor out 2m, which leaves me with m minus 3. Oops, sorry, I made a mistake there. Let's split it like this, okay, because we're not factoring the negative out yet. Now, in this case, to make the binomial same, I can factor out -1. And I'm left with m minus 3. Now, these are the terms that I have common, m minus 3 and m minus 3. So, like I said, you should have same binomial as your factor, just like we do. So we factor that out, m minus 3 is factored out, and we're left with 2m minus 1. And that's our answer. Let's check our work. Let's verify. So let's distribute it. M minus 3 times 2m minus 1. 2m squared minus m minus 6m plus 3. And now, oops, sorry. These are my like terms. So I have 2m squared minus 7m plus 3. And that's my answer. Or not my answer, but I verified it, right? My final answer is this. So take a moment, try these questions, and you can always check by distributing it. I'm just going to do part C for you guys. Okay, so this is same, right? So I can take that as A, whatever I want, A, B, C, D, whatever you want, except X, okay? So I'm going to substitute A as X plus 1. So it'll be 3A squared minus 2a minus 8. So my product, I cannot factor anything out, so I'll do product sum factor. And my leading coefficient isn't 1. So my product is going to be 3 times minus 8, which is -24. Sum is -2. And my factors will be -6 and 4. Okay, so I'm going to split my middle term, make it equal to these. Okay, so it'll be -6a plus 4a, and then everything else stays the same, -8 3a squared. So I'll factor out 3a from the first term, which leaves me with a minus 2, plus 4, factor out the 4, a minus 2. Now I have a minus 2, which is common binomial, so I'm going to take it out, a minus 2, factor it out, and I'm left with 3a plus 4. Now, guys, you need to remember that in this case, we have 1, 2, 3, 4 terms. But in this step, we have 1 term and 2 term, because these terms are being split by addition or subtraction. Okay, so make sure you know how to count your terms. Okay, let's move on. Factoring differences of squares. So this one is easy. Whenever you see an expression that's in a form a squared minus b squared, so something like x squared minus 4. Now 4 is a perfect square, so it'll be x squared minus 2 squared, right? All you need to do is do x minus 2 times x plus 2. Okay, and you can check your work. You can check if it actually works. So let's distribute this. A squared plus ab minus ab plus, minus b squared, because negative b times b is negative b squared. These cancel. We have a squared minus b squared. So it is equal. We verified that this works. But always make sure that your sign in between these terms is subtraction, not addition, subtraction. Always check for that, okay? So let's factor this. We know 9 is a perfect square. We see that the sign is subtraction. Both criteria are met. We have x squared minus 3 squared, which is just x minus 3 times x plus 3. And that's your answer. Try these questions on your own. I'm going to do part B and C, but try it first. So part B, I can see that greatest common factor of 3 and 75 is 3. So I'm going to factor out 3, which leaves me y to the power of 4 minus 25. Now, 25 is a perfect square. Y to the power of 2 to the power of 2 is also a perfect square. So I'm just going to break that down, and now I have y squared minus 5 times y squared plus 5 times 3. And that's my answer, okay? Part C, we could assume, now this is already a perfect square because it has a square over here, right? And we know 9 is 3 squared. So all we need to do is use the property again. So it'll be 3x plus 2 minus 3 times 3x plus 2 plus 3. Like terms, we have 3x minus 1 because 2 minus 3 is minus 1. 2 plus 3 is 5, so we have 3x plus 5 as our answer. Doesn't really matter if you add first or subtract first. Like over here, I subtracted first here. You can add first as well. So in a nutshell, what we did when it comes to factorizing, always check if you have a greatest common factor first so that you can factor that out. Then if you have two terms like a binomial, is it a differences of square? Does it have a minus and does it have square? If it does, use differences of square. If it's a trinomial, has 3 terms, then figure out if it's type 1 trinomial or type 2 trinomial. So type 1 would be when there is 1 as your coefficient. All you do is product some factor, whatever factors you get, you put them as your answer, okay? Like let's say your factors are minus 3 and 2, you'll just say x minus 3 times x plus 2, okay? Type 2 binomial, when a is not 1. So then you have to look at if you can, you'll have to see the multiples of the first and the last term. A and C will be your product. Your sum would be b, and your factors need to add to the sum or multiply to the product. And then you just break them into 2 pieces, group, and find the greatest common factor. That's it for today. And you have a handout to work on. Try these questions, and then the solutions are given here.